All right, so I have this question here under electricity. So it is showing a circuit, and this circuit has got a source of 20 volts, the EMF, and there are 3 resistors, 2 connected in parallel, but 1 is in series. And there's an ammeter here, and there's a switch at this particular point there. Question A1 says, find the ammeter reading when switch K is open. So when switch K is open like this, how can we find the current? We need to know that when this switch is open, let me use another color so that I can illustrate properly. When this switch is open like the way it is, current is not flowing through this. Okay, current is only flowing in like this, but not in here. So what we do in that case, we know that current equal to voltage over what? Resistance. Fine. Now that current is not flowing through this one here, it's only flowing through there and what? Through there. What do we have to know? What we have to know is that voltage is 20 volts. Fine. Then resistance, since now this and this one, they are not in parallel any longer, they are in series since current is no longer flowing there. So it's now these two and this one, they are in series. So this will be 3 plus 2. So 3 plus 2, and this will be 20 over 5. So volts, then this is ohm, and this will give us what? 4 amperes. Why did I add them directly? Because they're in series. Whenever resistors are in series, you add them directly. But when they're in parallel, you add them as fractions. Wow. 2 says when K is closed. When switch K is closed, what will be the current? Current is equal to voltage over what? Resistance. Voltage still remains 20 volts over. But does resistance still remain 5? No. Now that the switch is closed, current is now flowing here as well. So we need to take into consideration that we need to add these. We need to find the total resistance here. We also find the resistance there. So let's find the total resistance there. I'll erase here. So in this case, resistance is equal to, since they are only 2, it will be 2 times what? 2 times 2 over 2 plus 2. Okay? Plus this one in series, plus 3. So this will be 4 over 4 plus what? 3. This will be 1 plus 3. So this will give me 4 amperes. Okay? So I'm putting 4, sorry, not amperes, 4 ohms. 4 into 20, that would be 5 amperes. You've seen the difference, right? So this is how you find current in parallel like these two, like the way they are. Sorry, not current, resistance. Pardon my mistake. Okay, so then let's say they've asked you to find the current flowing. Okay, let me go to B. C. Calculate current in what? In the 3 ohm resistor and the okay, let me just do that. Okay. Now when they ask you to find the current in the 3 ohm resistor, how do we go about it? We need to take into consideration that this 3 ohm resistor is in series. So in series, current is the same. And in that case, this is the total current to flow there. So total current here, it will just be what? 5 amperes. Because that resistor is in what? Is in series. But what if I say calculate the current? I say C, calculate current flowing in the 2 ohm resistor Z. Okay, I want you to find the total current flowing here. How can you do that? You can only find current. You know that current is equal to voltage of what? Resistance, isn't it? Voltage in parallel is the same. Voltage in parallel, I repeat, is the same. So the same 20 volts here is flowing in this one, it's also flowing in this one. Hence, it's just the same there as 20 because those two are in parallel. Then resistance, the total resistance here, remember we found it was what? It was 1. So we are putting just a minute. Just a minute, let's use the ratios. If we have to find the current flowing in here, we need to take into consideration that, okay, let's use ratios, okay? Since the total current in this case is 5, right? It's 5. And here we have 5 current ampere flowing there. When we added this one, okay? When we added this one, it becomes what? 1 resistor, giving us this. And once we do that, remember we have this one here. When we add these two, they form 1 resistor. We are going to have a 3 ohm here and a 1 ohm resistor, like I said here. And these, they become in parallel together. Okay, they become more so in parallel, they become in series. Now that they are in series, that means there is the same amount of current flowing there. Okay, so even here current will be 5 amperes. Okay, so let's look at another question. Okay, the other question says define the term resistance. Now, what is resistance? Now, resistance is just the measure of the opposition to the flow of current in the electric circuit. So this is the measure of opposition to the current in an electrical circuit. That's all. Then 2 says 3 resistors, 3 resistors okay, the other question says 3 resistors, 2 ohms, 4 ohms and 3 ohms are connected in parallel in a circuit. Draw the circuit. 2 says find the effective resistance. So let's go. So since these two are in parallel, so we are going to have something like this. Okay, going to have something like this, another and like this. So these are connected in parallel. It's like this. Okay, so it'll be like that. So we're going to have the 2 ohm resistor here. We're going to have the 4 ohm resistor and the 3 ohm resistor, like that. So this is for 1. Then 2 says calculate the find the effective resistance. Now effective resistance, so is equal to, now we are not going to multiply like the way we did when they were 2. They are no longer 2, they are 3. So we are going to say 1 over 2 plus 1 over 4 plus 1 over over 3. So we are going to come up with a common denominator. Okay, common denominator, these are in parallel, that's why we are adding them like this. Common denominator here, where 2, 4, 3 can go, it's 12. 2 into 12 is 6 times 1. It's 3 times 1 is 4 times 1. And this would be 13 over 12. So let us divide 13 by 12. Okay, it's giving me 1.1. So total resistance is equal to 1.1 ohms. And that is how you find resistance in parallel. Let's look at another question. Okay, another question says define the following terms: a coulomb and a volt. So what is a coulomb? A coulomb is a unit of charge or you can say it's the quantity, okay, it's a quantity of electricity carried, okay, in 1 second by 1 ampere. Then to be a volt. A volt is just the what? The force carrying a charge in a second. Or you can say a volt is what? A volt is more like the difference in terms of potential, okay? But when we talk of the difference in terms of potential, we are still talking about energy, okay? Or we're talking about still the what? The force. Or you can say it's the what? The difference in potential, okay, carrying 1 ampere per 1 watt ohm resistance. Okay, let's dig into another question. The last question says, this is a diagram. I have drawn this diagram. Let me just put my ohms here. Let me just put a 2 here. Then let me put 6 volts there. It says calculate the effective what? Effective resistance. Now when we talk about effective resistance, we're talking about the total resistance. So we have these 2 in parallel and 1 in series. So we know what to do from there. So total resistance total will be equal to those 2 that are in parallel. We are going to multiply them because they're just 2. Then I'm going to add them again like this. Then plus the other one in series, we're just going to add it like that. So this would be 16/8 plus what? 2 ohms. And this would be 2 ohms plus what? 2 ohms. And this would be what? 4 ohms. That's the total resistance. Then B says the ammeter reading when the switch is what? The switch is closed. So when the switch is closed, to talk of the ammeter reading, we are talking about current equal to voltage of what? Resistance. Total voltage is what? 6. Total resistance, it's 4. So give me 6 by 4. Give me, it's 1.5 amperes. Let me also add another question. The reading on V. On reading on V, that is a voltmeter connected across the 2 ohm resistance. So how do you find the reading around that? We need to know that for us to know the voltage there, we need to know the current from there. So now remember that this current, the 1.5 which is flowing throughout the circuit, it's the same as the one which is flowing here because this is in series, okay? Since this resistor is in series, that means it has got also 1.5 watt amperes. So if it has got 1.5 amperes, we are saying voltage is equal to current times what? Resistance. Current is 1.5 times resistance is 2. So this will give me 3 volts, like that. Okay, so that is where we end. I'll see you in the next video.